So we'll be writing linear equations in this lesson. In the past we learned to graph linear equations. Now we're going to write equations of lines. And we're usually going to put our lines in slope-intercept form, although sometimes we'll put them in some other forms, such as standard form. And so there's four different situations that we'll be seeing in this lesson. We'll have a couple other situations as we move forward. So the four different situations are if we're just straightforward given the slope and the y-intercept of a line. That's going to be pretty simple to do because you can just plug that into y equals mx plus b form. If you know the slope, you put it in for m, and if you know the y-intercept, you put it in for b. The other ones are going to end up getting to that, but in number 2 we have a slope and a point on the line, but what we'll end up needing to do is find the y-intercept. The next one is you have 2 points in a line. Well, you can use 2 points to find the slope because we remember that slope is y sub 2 minus y sub 1 over x sub 2 minus x sub 1, and we'll see that formula a few times. So we'll use that formula, and then once we know the slope, we'll have the slope and a point, so it will kind of be like situation 2. And the last one is the graph of a line, which if we can see where it crosses the y-axis, it's really easy to write the equation of the line. If not, we can kind of use one of these other ways. We can find the slope using 2 points and then figure out what the y-intercept is. So we'll be talking through each situation and writing the equations. So as I mentioned, here's the first one, the slope. If you're given the slope and the y-intercept, you're simply going to plug in the appropriate numbers in for m, which is the slope, and b, which is the y-intercept, into the equation y equals mx plus b. So example 1 says, write the equation of a line that has a slope of -3/5 and a y-intercept of 0, -2. Well, this is telling us that's m, and then 0, -2, this -2 is going to be b. And so all we have to do is take y equals mx plus b, and we're going to put -3/5 in for the slope. Still leave the x here. Do not forget the x. That will totally change the problem if you don't. And then the y-intercept was -2, so we can put -2, or we could put plus -2. Same idea here. Write the equation of a line that has a slope of 3 and a y-intercept of 0, 5. And so y equals mx plus b. This is our slope. And this 5 is our y-intercept. That's b. And so we have y equals 3x plus 5. And that's the equation of the line. Pretty straightforward. To the next one, we do have several examples here, and we'll look through each one. This time we're given the slope. So we'll know the slope, we'll know m, and a point on the line. And so what we're going to do is we'll still use slope-intercept form. And as you look here, plug in the slope in for m. So we'll put the slope in for m, and actually we'll have a point. It's like an x value, y value. You'll plug the x value of the point in for x and the y value in for y, and that will help us solve. Next step, solve for b. And then once you have b, you will have b, and you'll have m, and you can plug them in to this form. So first one, write the equation of a line that passes through 2, -3 and has a slope of 5/2. Well, following the steps here, we're going to start with y equals mx plus b. We're going to plug our slope in. So step 1, plug in the slope, which was 5/2. We're going to plug our point 2, -3 in. So 2 goes in for x, and -3 goes in for y. And then we have plus b here. So notice here we have just b. There's no other variables, so we can solve for b. Looking at this, when we multiply fractions, the 2 reduces, and so we have -3 equals 5 plus b. we would subtract 5 from both sides. And when you subtract 5 from both sides, that's a 5, you get negative 8 equals b. And then we can plug that back in. So we solved for b, and now we're going to go back to y equals mx plus b, but we know that the slope is 5 halves. And then we have our x, and our y-intercept is negative 8, so we can put minus 8. And that's the equation of that line. So we followed through those 4 steps. And really, it's just practice from here. Next one, write the equation of a line passing to the point negative 4, negative 3, and has a slope of 1/3. So again, we're going to start off with y equals mx plus b. We're going to put in our slope for m, which is 1/3. We're going to put our point in for x and y. Our point for y is negative 3, and our point for x, our value for x is negative 4, and then you have the plus b. This one will end up with fractions in because this does not reduce, so we'll multiply there, and we get negative 4/3. And we'll add 4/3 to both sides. And we're going to run out of room here, so we're going to have b on the right side, and then we'll work this out, negative 3 plus 4/3. Well, in order to add fractions, we need a common denominator, so we will put this over 1, and we'll multiply this by 3 over 3 to get a common denominator. And so this is negative 9 over 3 plus 4 over 3 is equal to b, and then negative 9 plus 4 is a negative 5/3. And so b is negative 5/3. Now we can go back to y equals mx plus b. We can plug in the slope, which we knew to start with was 1/3, and we just found through the work that we did here that b is negative 5/3, so we'll put minus 5/3. And yes, you can change that. Y-intercepts, it is nice to have as a mixed number because you can find that on a number line a little easier. So we could write that as 1/3 x minus, and this is 1 2/3. And so that's the equation of a line. Either of these will do. And the last one, write the equation of a line that passes through the point negative 1, 3 and has a slope of 0. I'm going to go ahead and stick with what we've been doing, but at the end I'll show you something else we could have done that would have been a little quicker as long as you know your lines well and know about lines. So we have a slope of 0, and that's what I'm talking about. So when we go back and do this again, we'll be using that slope of 0, and hopefully you remember something about a slope of 0. So negative 1/3, or negative 1/3, I'm going to put 3 in for y, because that's our y value, and I'm going to put negative 1 in for x. And 0 times negative 1 is 0 plus b, so really this solved really for us, so we have b equals 3. And we can write y equals 0, our slope was 0, x plus 3. Well, what's 0, x? 0 times x is 0, so we really get y equals 3. And that should be familiar to us. We learned that y equals 3, y equals a number is a horizontal line that passes through 3. We could have found that earlier because we saw it has a slope of 0, and if we remember from before, this has to be a horizontal line. That's a horizontal line, and knowing a horizontal line, we know that has to be in the form y equals some number. And what number does that equal? Well, our point goes through the point negative 1, 3. Negative 1 is the x value, 3 is the y value, so it has to be this 3. So y is equal to 3. That's another way, without doing all that work, we could have realized the equation is y equals 3. So that's the second way, or second situation where you know the slope and a point on the line. the next one is really one step removed from this, one step more than what we did in this section here. And in this one, we just have 2 points. Well, if you have 2 points, you can first of all find the slope using our slope formula. Once you have that, you'll know the slope, and these steps here are the exact same 4 steps as the last type of problem. So the only difference is when you go to plug in your point, the x value and y value of your point, we'll have 2 points. You can really choose either point, it doesn't matter. So that's the only difference. So write the equation of a line that passes through 4, 1 and -2, 3. Well, what we're going to do first is we're going to find the slope. So slope equals y sub 2. So I'm going to make this my second point and this my first point. So y sub 2 is 3 minus 1 over, since I started with 3 on top, I need to start with the -2 on the bottom. So -2 minus 4, and that is 2 over -6. That reduces by 2, so we have 1 over -3, which we can write as -1/3. So now we have our slope, and we have a point, and we can use either one of these points. So now it's going to be like the problems in the last situation, y equals mx plus b. We're going to put -1/3 in for our slope, and we can choose either point. I'm going to go ahead and choose this point. So I'm going to put 4 in for x and 1 in for y, and then I can solve for b. So this multiplying this is -4/3 plus b. I would add 4/3 to both sides. And to add these, you need a common denominator, so we can think, well, I'm going to multiply this by 3 over 3. Well, 3 over 3 times 1 is just 3 over 3, so we have a 3/3 plus a 4/3 is 7/3. And so b is equal to 7/3, and then we can come back to our original y equals our slope, which we found to start with, plus our y-intercept, which is 7/3. And that's the equation of the line. Let's go with our next one here. Write the equation of a line that passes through the points 8, 2 and 8, 7. I think that's supposed to be. I accidentally wrote in there. I think I did that a couple places. And so first we're going to start with finding the slope. And we'll do y value minus y value. So let's do 7 minus 2. It's y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Well, this gives us 5 over 0. And we know we can't divide by 0, so this is undefined. Now, when we have an undefined slope, we can't put it in slope-intercept form, but we do know something about an undefined slope. We learned that an undefined slope means that we have a vertical line. And if we have a vertical line, we know it is in the form x equals some number. And what number is that? Well, it's the number that our points go through. So what is our x value here? Well, our x value is 8. So x equals 8 is the equation of this line, which is a vertical line. And we knew it would be that way because we had an undefined slope. We're going to go ahead and use this here, and then we'll get to our last type of example. The planning committee for the city of Brownsville used census data to project the growth of the city. Determine the estimated growth rate and write the, well, we don't have any information here. I messed up something there. So we're going to skip that, and we're going to go to this step, this next one right here, and maybe we can come back to that example at the end. So this is actually another easy way to graph lines, or write the equation of line if we have the graph. So what we're going to do is we're going to locate the y-intercept, we're going to find the slope by using two convenient points. And then lastly, what we'll do is we'll just plug the y-intercept and the slope into y equals mx plus b. So here we see the y-intercept is 0, 4. So our y-intercept is the point 0, 4, and so that 4 is going to go into our equation. And then the slope, we can choose that point, and then when I say convenient point, I mean ones that cross these lattice points here. So let's pick this one right here. So to find this slope, we can start here. We go down 1, 2. So that's our rise is -2. And our run is 1, 2, 3 to the right. So that's a +3, which we can write that as -2/3. And now what we're going to do is we're just going to plug in these values into y equals mx plus b. And we have our slope is -2/3. And the y-intercept we found was 4. And that's the equation of that line. And so we went through those 4 ways, 4 situations: slope and y-intercept, slope and a point on the line, 2 points on the line, and the graph of the line. And we are going to go ahead and skip that example for now. And so that's writing equations of writing linear equations.